ma wo fefwe wo yi ma wo suda ni munya fwe ni peja wudido to me di fwe yi me yi wa yo dadie ye be ma uswo na shawen nyamda my granote sawu obiara ni wo.
Good day and welcome to our today's lesson of plain geometry 1. Okay, the next one after this is going to be plain geometry 2, which is the circle theory. So this time around we'll be dealing with plain geometry 1, where we'll be looking at interior and exterior angles of regular polygons, and if you have parallel lines, and what are the angle laws and all those things. So that is basically what we'll be looking at in this chapter. Okay, that is basically good. So now when we say interior and exterior angle, what do we mean? Supposing we have a specific line like this, okay, and then another one which joins it to form maybe triangle, or it can be any shape at all. It can be rectangle, whatever shape. Now when we say interior, that means inside this specific shape, the angle that is within it is what we call interior. Okay? And then the angle that is external to whatever line is what we call the exterior. Okay, so anytime I refer to any interior, it means the angle that is within, and exterior is the angle that is outside. Okay, very well. Now before we look at this mainly, we are supposed to note some specific rules or relationship with angles. Okay, so I'll mention the name and then we are going to look at what relationship do they have, right? So for instance, let's say I give you a shape like this. Two lines like this, say line AB and then line CD. Okay, you have line AB and line CD. You know definitely line AB and CD meet here. So they intersect. And whenever they intersect, they will form an angle, okay, between them. So when there is an intersection of line, there is an angle there. So it means that here will be an angle, say A. Here is definitely an angle, say B. And then this is an angle, say C. Okay, let me use C. And then this is an angle, say what? D. So we have A, small letter B, C and D as the angles when you are having a certain shape like this. Okay? So fine, let's now establish the relationship that exists between these four angles. So the relationship that exists between the four. Now look at this. With the very first one, we have one relationship we call the vertically opposite. The vertically opposite relationship, okay? So the vertically opposite angles per the name, vertically and then they are opposite, right? Vertically and they are opposite. That means that when you draw a line, they should be in line, okay? But opposite of each other. So for instance, the position of angle A, do you see? And then the position of angle D. So if you look at them, angle A is here and then angle D is here. Now when I draw this line, you see it's a vertical line, right? It's a vertical line. Now, this is at the other side of this vertical line, and then this one is at the other side. Hence, we say that, okay, when we have any two angles created by the same line that are intersecting, then the angle created just opposite this one is what? Vertically opposite. And that means that the two of them are what? The same. So for vertically opposite angles, they are just maybe formed by the same line that are intersecting, form at the opposite sides of the line. So in that case, due to vertically opposite, then we say A and then what? D are the same. Okay, vertically opposite. So you can say that A and B are the same. A and B are the same. Likewise, if I have this one, B and C, okay, so B here and C here, B and C. The same way I can turn this anyhow I want, okay. So the same way if I draw a line, then this same line and this same is what is forming this angle, and the same line is what is forming here. So this one is exactly opposite where this is, and they are on the same line. Therefore, we say what? Then this is vertically opposite. Hence, by virtue of vertically opposite, A is the same as D, and hence B is also the same as C. So whenever we see this one here, let's not be confused. So B will be the same as C. Okay. Now, after vertically opposite, we have what we call angle formed on a straight line. Okay, angle formed on a straight line. Angle formed on a straight line. So let's say a straight line. A straight line. Okay. Now, what do we mean by angle formed on a straight line? Supposing we have a straight line like this. Okay. This one is mainly like two angles that are on top of each other, but because of how they are placed, it's as if it's only one line. Okay, so when you have to get the angle that exists between the two, then we say, oh, we are going to get the angle like this. Okay, we are going to get the angle like this, and clearly you can see that this is more like what we call a semicircle, because the whole thing is like half of what? A circle. So this is more like what? A semicircle. Okay. So if we establish that the total angle within what? A circle. The total angle within a circle is always what? 360 degrees. So the total angle within a circle, a complete circle, is 360 degrees. Okay, so when that is established, then half of this, which is what? The angle formed on the straight line, that's a semicircle, half of that one is going to give you what? 180 degrees. 180 degrees. Okay, so anytime you have some angles on a straight line, whatever, when you sum all those angles there, they are supposed to give me 180 degrees. So for instance, what we have here, if I should divide it like this and like this into angles, say A, B, C, then what we are trying to say is that the angle A plus the angle B plus the angle C should be equal to 180 degrees, because they are all formed on a straight line. Okay, they are formed on the straight line. So more like this, 180 degrees. So when we come here as well, when we pick this line AB, then you can see clearly that angle B and A are on the line AB, as well as angle D and C are also on it. Same way, angle A and C are also on CD, and then B and D are also on CD. Okay, CD. So in that case, if we are using that diagram that we have, if we are using the diagram, then we can say that angle A, right, plus B should be equal to 180 degrees. Okay, should be equal to 1 degree. Same way, angle A plus C should also be equal to what? 180 degrees, because we are also on this line. The same way, C plus D should also be 180 degrees. So it goes on, and then B plus D will also equally be 180 degrees, because all of them are formed on the straight line. Okay, all of them are formed on the straight line. So notice that if you have angles formed on a straight line, then it's all sum up to 180. So supposing I give you a question like this. This here, this is 2x, this is 37 degrees, and then this is say 40 degrees. And they ask you to find the value of x. It should be very simple, because we've established that, okay, all these angles are formed on a straight line. So if they are formed on a straight line, then it means that the sum of all the angles on a straight line is 180 degrees. Therefore, I can say 2x plus 37 plus 40 should be equal to give me 180 degrees. So here you make x the subject. Just add this and that. That is going to be 77. You subtract it 103. Then you divide it by 2. Okay? So 103 by 2. And then the value you get there is the value for your x. Very good. So that is how basically some of those questions can be placed. Okay, some of those questions can be placed. Good. Now, we also have a right angle triangle. Right angle triangle. So we are dealing with the angle. So let's say right angle. Okay. When we say right angle, it just simply means 90 degrees. Okay. 90 degrees. So just like this is straight line, right angle, and then a complete circle. So circle, straight line, right angle. That's how it is. So right angle will give you 90 degrees. So supposing I'm having an angle like this, then I mark here to be this. Then this is what's called the right angle. So I can do the same thing I did here. Divide it into sections. And say here is 3x, 25, and then 30. Then I ask you to sum and find the value for x. Since you know that here is a right angle, then it means that 3x plus 25 plus 30 should be equal to 90 degrees. Then you make x the subject. Cleanly simple. Okay, so this one here should be established. Okay. Now, there are certain terms we give to angles, okay, depending on their range of values. Then we will give them certain names or certain class. Okay, certain class. For instance, we have a class called an acute class. An acute class is coming from the word cute. So if they say something is cute, you are cute. You are not that big, no, that's so you are sizable. Okay, then you are cute. Oh, these are cute. Yes. So acute angle. So when we say acute angle, it means that the angle is not too big, it's not too small. You get it? So it's between 0 up to 90 degrees. So when it's 0 up to 90 degrees, then we say it's an acute angle. Right? It's an acute angle between 0 and 90 degrees. Right? Good. So then this is the angle greater than 0, less than 90. Okay. When we have this one here, then we say what? You have acute angle. So if I draw an angle for you like this is an acute, an acute, an acute, an acute, like that. Provided the angle is less than 90, it's supposed to be treated as one. Okay. Now, if you have that, then from acute, then we go to right angle, which we give it, right? To right angle, and then we know that right angle is what? 90 degrees. Straight. No difference. Then, if that's the case, then we have something we also call obtuse angle. Obtuse. Obtuse is more like an acute that is bigger than 90. What I mean by that is, you see, acute is maybe any value between 0 to 90. So 60, whatever, 20, whatever, like that. They are acute. Now, when you add that value to 90 degrees, whatever you get is going to be what? Obtuse. So obtuse then is an angle that is greater than 90, but it's less than what? 180. So between 90 to what? 180 degrees, then you have what we call what? An obtuse angle. An obtuse angle. So with that one, it can be spread like this: 120, 150, 170, 179, and the rest. So those ones, they are all what? Obtuse angles. Okay. So after obtuse, then we go to the straight line, which is complete what? 180 degrees. Complete 180 degrees. From there, go to straight circle, and so on and so forth. Okay, and so on and so forth. So at the very beginning, these are the things you need to know: vertically opposite, straight line, right angle, area of angle of a circle, acute, obtuse, and all that. Okay. Let's now go to a situation where we have two parallel lines that are having some relationship. Okay, so let's move there. Okay, so angle properties of parallel lines. So angle property of parallel lines. Very good. So we established that when we have any two intersection lines, vertically opposite, on the straight line and all that, we got that idea right. Now, supposing we have two lines, which is line A, B, and then let us write it this way. Okay, you let go. Line AB, then we go this way. Say line CD, and then line EF. Good. Now, they told you that, let's say line CD and then line EF are in parallel. So they have these two lines CD and then EF being in what? Parallel. When that happens, then they exhibit a certain property on line AB. Okay? Now, supposing this line AB forms an angle here called A, and then this here is B, that is C, and then this here is what? D. Clear here to E, F, G, and then what? H. So this is the angle formed by what? Line AB on these two parallel lines. Very well. Provided we are sure that CD and EF are in parallel, then the angles that are there from A to H are going to have certain relationship, okay, which we are going to establish. Very well. So now, what are the relationships? Now, when you look at positions, okay, when you look at positions, the very first one we can clearly see, the first demonstration is A and B. You realize that A and then B are formed on a straight line. So that one we know that A plus B is going to give us 180 degrees. So angles on what? A straight line. We are aware of that. Same way, A plus C will do the same thing. And then B plus D will also do the same thing. C plus D will do the same thing. E plus F are also on this straight line. E and G are also on this line. G and H are also on this line. And then what? F and H are also on this line. So all of them can exhibit what? The angle on the straight line. Very good. Now we can also identify vertically opposites. Because this line and this that are crossed are meeting here. Then A and D are the same. So A is equal to D because of what? Vertically what? Opposite. And the same as C is equal to B as well. So C and then B are also the same. Likewise, G is also the same as F. So G is equal to F, and then what? H. E is also equal to what? H. Then we call this what? The vertically opposite what? Angles. So that's vertically opposite angles. Very good. So then, with this one we tackled it in the previous. Now let's come to additions. Additional angle properties. Now look at something. When you look at E and then this line, they form angle E over here. Do you see how the shape goes? The shape goes like this. That's how the shape goes. Translate the same thing to this line here. Then you realize that, okay, C and then B also form the same angle. But this time around it's called A. So that one too, the shape is like this. You see? On the same line. So these are the same line that is causing the wahala. And these are also in parallel. Hence, then we can say that, okay, then the value over here and then the value over here are the same. So we can say A is equal to what? E. A and then E are what? The same. And A and E being the same, the name given to that is what? Corresponding angles. Corresponding angles. When you look at their exact position, then you have to check here and see that, okay, the way this is the same orientation. So this and this are what? Corresponding what? Angles. Fine. Established. Full. Fully. Very good. So here, if we know A and E are the same by virtue of their position, then it's also clear to know that B and then F are also the same. Because of, you see how it's also oriented. The same thing. So B and then F are also the same. So here too we can say B is the same as what? F. Okay, B is the same as F. Okay. Now here, the same thing can be done for D and H. So D and H are also what? The same. We call it what? The corresponding angles. This and that. And then this and this are also what? Corresponding what? Angles. So in terms of corresponding angle, the position you are occupying here is the same position I'm also what? Occupying here. If that is the case, then we say that two of you are the same. Provided they are parallel lines we are dealing with. Okay, so before identify how to do corresponding angle. Now let's see if we can identify any new property. The new one is called alternate angle. Alternate angle. Now what do we mean by alternate angle? If I am at this position, okay, if I am at this position here, okay, then at the other end here, I must be at the opposite side, occupying the same orientation, but what? Opposite side. So what I mean is that if you look at how E is and how D is, then we say they are alternate angles. So E here and then that of D are alternate. So you can see the way D is spread is the same way D is spread. Just that it's not spread at the top, it's spread at the down. That's why we say what they are alternating. If not this, that. So alternate angles. So E and then B are alternate angles. Same way, you see the position this one is occupying here, right? This position and then B are also alternate. So this one and then this one are also alternate. Then you have this and then this are also alternate, like that. Okay, so then they will give that specific property as E being equal to D, H being equal to A, G being like that. Okay, to show they are all alternate angles. Now, so let's go on to look at that one, new one, because we've been able to establish corresponding, we've been able to establish what? Alternate angles. So let's go to the very last one, which is what we call the co-interior angle. The co-interior angle. Co-interior. Now, when we use the word co, even in English language, co means what? We are normally like the same. Okay, it's my co-equal, my colleague, my co-this, my co-that. Okay, so when we say co-interior, then that means that co means we are the same. So we are both an interior angle, positioned at the same place. Okay, so when we say co-interior angle for this, so when we say co-interior angle for this, then we have what? You see the position where D is. D is here, and then F is also here. So they are both inside and inside. I already explained what interior means to you. So this is inside, this is also inside, and they are both at the right hand side of what? The line. So then we call D and F as co-interior angle. And so we say for co-interior angles, then that D plus what? That F should be able to give me what? 180 degrees. So the sum of two co-interior angles are supposed to give me what? 180 degrees. Same way, E and then C, they are co-interior angles. So this one we have two of them. This one and this. This one they are exterior. These ones are the only interior angles. You can actually take notes or take reference. Okay, good. So for angle properties of parallel line, then you are going to be looking out for alternate, you are going to be looking out for a corresponding, you are going to be looking out for right angle, triangles, and all those things, depending, right angles, depending on what the question is asking you to do. Okay, it's asking you to do. So basically, if we are proceeding to find angles, right, and then we mention alternate, because this side here is alternate to this, you understand why it is so. When this is alternate to that, you understand why it's so. Because I'm occupying the same position, you look for the same position but on the opposite side of this side. Okay, the same line. Very well. So that is it for the very first part of what? Our video on plane geometry. I believe it has been very simple and easy, and if you have any challenge, you can repeat it and repeat it until you have mastered the specific terms and things we've given to you. Okay, so we shall move on to looking at interior and then exterior angles of what? When we are giving polygons. Okay, when we are giving polygons. So stay tuned to the next video. See you there. Bye bye.
Obiarendi wo Oime yiwayo Mesha wenu nyamda White granote sewu Obiara ni wo. My granite is a oh, my granite is a Obiara ni wo. Wonyi me yiwa yo.